7.5 radians. What are those, Miss Gilchrist?
They're pretty rad.
Oh, you see what she did there? Rad. All right, moving on. So here's what we should know right now. The first thing we should know and understand in life is that there are different ways to measure things. Ms. Gilchrist, you want to take this part?
Yeah, I like to measure things in feet, but people across the pond, they like to measure things in yards, or what else do they know? We measure in yards. So
Meters,
yeah. I like to measure things in gallons. They like liters, just a whole bunch of different ways to measure things.
And so we have degrees, and now we're going to have radians. And we have most of our unit circle already done.
Oh my gosh, we've done it so many times, right, Mr. Osborne?
We have to do it again.
We have to do it again. Are you kidding me? Hey, practice makes almost perfect, so.
We know the degrees and we know the coordinates, and that's really bad writing. But these are things we know and we are going to build on. So here we go. And we're going to start out with a definition. Radians are found by taking the arc length and dividing, I guess I should put length, the arc length and dividing by the radius. And since we're dividing by the radius, it doesn't matter the size of the circle. Ms. Gilchrist, I think you wanted to interject something.
Oh, I just wanted to ask a quick question about things we know already. Just for yourself, what's the radius of a unit circle?
Oh, the radius of a unit circle is
1. That's pretty
Good
cool.
point. Good point. So here we go. The arc length. Well, if I have an angle, this right here is the arc length. That's what we're talking about when we talk about arc length. And so let's look at an entire circle. If I go all the way around the circle, what is the arc length, Ms. Gilchrist?
360 degrees, or
if we're finding circumference, for those who don't know, that's 2 pi r. And if we divide that by the radius, we come to find out that there are 2 pi radians in a circle.
it's super rad.
That is super rad. So how many degrees are there in a circle?
360.
360. How many radians are in a circle?
2 pi.
2 pi. So let's think about this for a second. All right, we know this is, if I go all the way around, finish here, we know that's 0 degrees, and now we know that is 2 pi radians. So the question becomes, Ms. Gilchrist, what if I only took half the circle? What if I went here to 180 degrees?
Well, I would just divide 2 pi by 2.
So this would be pi radians.
Correct.
Okay. Well, what if we keep splitting it up? What if we went right here?
Well, that's just splitting in half again, so I would do pi divided by 2.
So that's pi over 2 radians.
Right.
What if I took that and went in half?
If I cut that in half, I'm going to divide pi over 2 by 2, which is pi over 4.
Okay. So what we're going to do right now is we're going to stop for question and answer time. Okay, so let's look at the size of our angles that are of the size pi over 2. If I were to shade this in, this angle here, this piece here of 90 degrees is 1 pi over 2.
Yep.
And this one would be 2 pi over 2, which is why we have 1 pi.
Correct.
So what would this, if I go all the way here to this angle, Ms. Gilchrist, what would that be?
It sounds like I'm just counting. So I have 1 pi over 2, 2 pi over 2, and then I have 3 pi over 2.
So there's 3 pi over 2, and then when I do this one, I'm at 4 pi over 2, and that's 2 pi. So let's put this on our unit circle. You have one already filled out, mostly, and so we should have 0 pi radians. We should have pi over 2 radians. We should have pi radians. We should have 3 pi over 2. And then we should have 2 pi radians.
And I bet
Everybody should
some-
have that.
Yeah, I bet some people are so happy to fill in that extra blank these days. I don't know about your kiddos, but mine have been really worried about that extra blank on the unit circle.
Ready to finish it off.
And
Okay, so now we've talked about what if half of pi over 2 is
pi over 4.
pi over 4. So let's start counting these sizes. Okay, so 1 pi over 4,
2 pi over 4.
which is pi over 2 we already have. So this one is now,
3 pi over 4.
then we have 4 pi over 4,
5 pi over 4.
5 pi over 4,
6 pi over 4, which
Wait.
gives me 3 pi over 2 when I reduce.
then 7 pi over 4, and 8 pi over 4, which is 2. And notice this is our pi over 4 family. It's a family of pi over 4, which was our, 45 degrees,
Yeah.
135 degrees, 225 degrees, and 315 degrees.
And they're the ones that have the same x and y coordinate too.
And they're the one that are the same x and y coordinates. So you should already have this filled in. I'll fill it in quickly. And now you can see I got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so notice I used a different color.
Yeah.
So maybe you should be using a different color.
That's a good plan.
And we have different sizes. So the question is, how big is this slice of our 1 pi?
Well, if it were me, I would count those pieces of my pie.
Okay, so let me count the pieces here. That's 1, 2, 3, 4, 5, 6. And that makes sense because these are 30 degrees.
Right.
And out of 180 degrees, 30 degrees, there are 6 of those pieces.
Right.
So what do we call this angle in radians?
I would call it 1 pi over 6 because I'm dividing my pie into 6 pieces.
So that's 1 pi over 6. So this one right here would be,
2 pi over 6. But I
But-
need to reduce that probably.
right, so we present numbers reduced, so that's pi over 3.
And then we already have pi over 2, but that's really 3 pi over 6 because we reduced it.
Okay, and so can we trust our students to keep going that way?
I think we can. We just count by 6s, guys.
And make sure you reduce.
Right.
All right, go ahead and do that. And here you go, and notice our families. We have families. We have our pi over 6 families, and these are all the ones with the reference angles of 30 degrees.
Same ordered pairs.
And then we have our pi over 3 family, where they all had, where they all shared the same ordered pairs as well. Right now, everybody needs to pause, and we're going to have a short question and answer time.
All right, so now we're going to learn how to convert from degrees to radians and radians to degrees, the same way you would do other measurements in conversion, especially in your science classes. Probably you do a lot of this. So I'm going to choose this right here as my point to get my conversion factor from, because I know this is 180 degrees, and 180 in pi don't reduce anymore. So that's the good starting point that we're going to use. All right, so we're just going to jump right into this, and we're going to try to convert pi over 3. And so we want the pi to go away when we're going from radians to degrees because we don't really hear, degrees having pi's in them. So the thing that I think we should do, we know we have 180 in pi, so we want the pi to go on the bottom so they can reduce. And my other number that we just looked at was 180, so I'm going to put that on top. All right, and I forgot my degree sign. Sorry about that. Okay, so now when I multiply this, I see that I'm going to have this reduced, so my pi's are going to reduce. And I'm going to do this in 2 steps for you guys. And then I'm going to be left with 180 degrees divided by 3, which equals what?
60 degrees.
60 degrees.
So go back one side, Ms. Gilchrist, and show them. Find 60 degrees.
So there's 60 degrees, and that one was on the unit circle, so that was pretty easy breezy.
Voila.
All right, so what if we have one that's not on the unit circle? What if we had pi over 18? Well, we're still going to do the same thing. We're going to multiply by 180 degrees divided by pi. And remember, we want the pi on the bottom so that we can reduce these two things out. So we're going to be left with 180 degrees divided by 18. And I know you don't need your calculators for this one. It's going to be what?
10 degrees.
Good job. All right, so what if we want to go the other way? Well, that means that we want to introduce a pi into our measurement because most of our radians, or all of them actually, have pi's in them. So I'm going to want the pi to be on top this time, and my other factor will be on the bottom. So now I'm going to multiply across. I get 210 pi divided by 180, and this can be reduced. So I can reduce out the zeros, and then 21 and 18 are both divisible by 3 to give me 7 pi over 6.
And we can confirm that on our unit circle because we come over here and we see and we know that 7 pi over 6 is 210 degrees. Last one, so let's say we have 340 degrees and we want to convert that to radians. So I want my degrees to reduce, so I need my degrees in the bottom. My pi is in the numerator. My degrees, my units reduce, and I have 340 pi over 180. Now we need to reduce. Divide our tens, and we get 34 pi over 18. Both of these are even numbers, so if I divide by 2, in the numerator and denominator, you get 17 pi over 9 radians. So there we go. We now know what a radian is. A radian is the arc length divided by the radius. We know how many are unit circle. We are able to convert degrees to radians and back.